In this video, we're going to discuss phase changes a little bit more. So here I've tried to summarize all of them. Our three phases that we're considering are solid, liquid, and gases. And the changes between these phases each have different names. And also they are either endothermic or exothermic. So when we go from, fusion should be green. When we go from a solid to a liquid, our molecules are gaining motion or kinetic energy. And that means they're going to start breaking their intermolecular forces and reforming them. And so this requires inputting energy. To gain that kinetic energy, it has to come from somewhere. And so the system is endothermic. Just like an endothermic chemical reaction, it's going to absorb energy from its surroundings to go from a solid to a liquid. And the name of this is called fusion, although most of us know it by melting, which also works. Then once you're a liquid, if you absorb more energy, it becomes a gas. And so our particles get even further apart from one another, and they gain more kinetic energy. And again, they're going to do that by absorbing that energy from the surroundings around it. So again, an endothermic process. And another way you could think about this too is going from a solid all the way to a gas directly. And when this happens, we call it sublimation. When we go from a liquid to a gas, we call that evaporation. We also sometimes call it vaporization. A great example of a solid subliming to a gas is dry ice. You'll have solid dry ice that just slowly disappears without ever forming a liquid. And that is called sublimation. Now, there's also the opposite of each of these. If you're a gas particle and you become a liquid, it's called condensation. Kind of like condensation or dew in the morning is water that's condensed from the air because it is so cold in the morning. And in this process, we're going from something with a lot of kinetic energy to less. So we are actually losing kinetic energy. And so that means that has to go somewhere. It's going to be released into the surroundings as either heat or light. And so it's an exothermic process when we go from a gas to a liquid and we condense. Similarly, when we go from a liquid to a solid, we call that freezing. And it also loses kinetic energy. These particles are slowing down and staying in the same spot as a solid. And that will also have to release that extra energy that the liquid had compared to the solid into the surroundings or the stuff around it. So it will be exothermic. And if you want to do this all in one step and go from a gas all the way to a solid, you're going to have to release a lot of energy to slow everything down. And we call that process deposition. And it is also exothermic. So for this class, it's important to know what these phase transitions are called, but also whether or not you expect them to gain or release energy through that process, if it's exothermic or endothermic. And so the following slides just walk through these a little specifically with an image to go along with it, looking at water. And I think water is the one that we are the most intuitive about phase changes because we have all interacted with ice, we have all interacted with water, and we have all interacted with steam, which are three phases of water. And so we can go from solid ice to liquid water by melting, and it'll absorb energy to do that. Or it releases energy as it freezes, which means that its surroundings get warmer. That's why we use refrigerators or freezers to freeze water. It's so cold that it pulls the energy out from the liquid water, and that forms solid water. Vaporization is when our water molecules become gas molecules, and this is like boiling as well, we can think of it. And it's going to need to absorb energy. You have to put something on a stove to get it to vaporize faster or evaporate. And the opposite would be condensing, as we take a gas and we condense it back down to a liquid. Sublimation, a better example is carbon dioxide, as we already discussed. Our solid carbon dioxide will sublime into gas, and our gas carbon dioxide we can actually deposit under pressure into solid CO2. And this is a phase change diagram or a heating curve to show temperature relative to the amount of heat that's added or energy. So this is like putting something on a stove and increasing the temperature. So if I start at a low temperature, I'll have a solid. And as I add heat, the temperature will increase. So as I add heat, I see the temperature rise until I hit my melting point. Now at my melting point, I'll continue to add heat, but all of that heat now that's added goes into converting a solid particle into a liquid particle. And that means it's going to move around more. So that heat added is going into the molecules so they have more kinetic energy and can move more. Now, this process will be called melting, and the temperature is constant. And that's how you know that something is undergoing a phase transition, is that constant temperature, which is a big component of this. Now, once the temperature stops being constant, starts increasing again, we'll notice that we've actually melted everything. So once everything becomes a liquid, at that point, as heat is added, we'll again see temperature increase. And temperature will continue to increase until we hit our next phase transition, which will be vaporization, evaporation, or boiling, depending on which word you prefer. And at that point now, all the energy that's inputted will go into converting that liquid into a gas and having more kinetic energy. So those molecules need more kinetic energy. The heat that's added goes into each molecule so it can move around more. And during this phase, again, we're going to have a constant temperature as that phase transition occurs. This constant temperature is the boiling point temperature, whereas for melting, we had a melting point temperature. And once every single particle becomes a gas, our phase transition is over. And again, as we input heat, the temperature will increase. You can look at the opposite of this too, a cooling curve. Here you start at a high temperature as a gas. And as you lower it, so you have to remove heat. So it's kind of like putting it in the freezer. Or the fridge. So as our temperature decreases, we'll eventually hit a point where we hit that phase transition again. So this is the same temperature as the boiling point. And it's now that we're removing heat, instead of going from a liquid to a gas, we're going to go from a gas to a liquid. So at that exact same temperature, we'll have condensation occur. And again, the temperature will remain constant. Once all of the molecules are converted into a liquid, then we'll see temperature start decreasing again as we remove heat. And that'll continue to happen. Our liquid will get cooler and cooler and cooler until we hit our next phase transition. And this is the same as our melting temperature. At that same temperature that a solid would melt, a liquid will freeze. So if it's water, that's 0 degrees Celsius, right? And so then we'll have a constant temperature as the phase transition occurs. And here it'll freeze, and all of our liquid particles will become solid. And once everything is a solid, then we'll start to see the temperature decrease again. And that solid will get colder and colder as we remove heat from the system. And here is just another way to summarize what we've said in the last slides. What all of our phase transitions are and whether or not they're endothermic or exothermic.